Hello everyone, I'm Shan. This video is for EL6303 probability and stochastic processes. I'm going to explain the first two questions of homework 2. Now let's do the first question. The customer flow at a grocery store can be viewed as a Poisson process, and the expression is given. Suppose the probability that in 2 minutes at least one customer arrives equals to 0.3. Then to solve 4 small questions. Let's do the first small questions to find lambda. We know in 2 minutes, at least one customer arrives equals to 0.3. That means in the expression, it's like this. Here is t, here is k. It means at least one customers means it's larger than one. So we know the inverse event of this situation is no customer will come. So here we get the number of customer arrives in first minutes. Here k equals to 0. We get its probability is 1 minus 0.3. Is 0.7. So let t equals to 2 and k equals to 0, and we can doing a simple computing and get the lambda value. It's almost equals to 0.178. And next question, to find the probability that in 10 minutes at least 2 customers will arrive. So here t equals to 10 and at least 2 customers means k larger than no less than 2. So if we know the probability when k equals to 0 and k equals to 1, we can use 1, the whole probability to minus these 2 situation, and we get this one. So here let t equals to 10 and k equals to 0, we get in the 10 minutes no customers will come. Its probability equals this, and similarly we get the only one customer comes in 10 minutes. Here t equals to 10 and k equals to 1. The probability is 0.3. So the probability that in 10 minutes at least 2 customers will come is equal to 1 minus this situation and this situation. So the final result is 0.531. The third question, find the probability that in 1 minute exactly one customer will arrive. So here t equals to 1, exactly one customer, so here k equals to 1, and we from the expression we know the final result is 0.149, and the fourth question is similar as the third one, but the only difference is t equals to 3 and k equals to 0. So finally we get the whole results. Okay, let's focus on the second question. Given that density function fx expression and to solve these 5 small questions. Let's do the first one. To find the a, so that density function fx is a valid density. So we know one of properties of density functions is it's integral on the domain from minus infinity to infinity equals to 1. So we use this to solve the problem. Here we know the first item. Here it's impulse function, and impulse function expression is like this, and its property is it's integral on the interval minus infinity to infinity is equal to 1. So the first the integral of first item is equal to a times a times e to the power minus 2. This is the first item, and the second item it's from 0 to 1, and it's density function fx is equals to this. So we use basic integral operation to get its integral. And the third item 0, so it's still 0 here. And after by doing some simple operations, we get a equals to 1. The second question, sketch the density function fx. Before we draw the fx, we have to know some special point, like fx0, or the right limit of fx0 and its derivative in order to draw the slope, and also for left limit of fx1 and also its derivative to get the slope of this point. And besides, we also to determine that fx, the derivative of fx, and the relationship of the derivative of fx and 0, because we have to know the curve will be like concave or convex. So here the derivative of fx larger than 0 in this interval, so it's a concave function. So here we can use a special point to determine the basic shape of the function, also the density function. So this is it's the shape. Okay, the third question, to write density function fx in one line by using step functions. We know step functions is equals to 1 when x larger than 0, and equals to 0 when x less than 0. Here we define if x equals to 0, the ux equals to 1 here. So ux is used to limit the interval of the density function. So here we use ux to express this interval. So here is it should be ux minus x minus 1. This is equals to this interval. So here a is equals to 1. We have gotten this, and so easily we can get the final expression. Okay, the fourth one, find the distribution function fx in analytical form. And we know by definition, distribution function fx equals to the probability of the random variable x, no less than this x, and also equals to the integral of the density function fx in the interval from -infinity to x. So here it's this question is similar as the first one. The only difference is this one is a definite integral, this one is indefinite integral. So here after some simple operations, we get here is a constant c. We have to determine what c is, and since we know in the point x equals to 0, and its probability is e to the power -2. So here we can get the c. And finally, we get the expression of distribution function fx is like this. The final small question to sketch the distribution function fx. Before we draw the curve, I'd like to determine this curve and this curve to explore what's the relationship between them. So here, this is ye equals to e to power x minus 1, and this is y2 equals to e to the power minus x minus 1. And I'd like to turn over this curve about the x to get this y3 equals to minus e to the power minus x minus 1. So the final result is to add these two curves and also the constant e to the power -2. So we can to determine some special point and get the basic shape. So here when x equals to 0, fx0 is equals to e to the power -2, and when x2 equals to 0, x equals to 1, fx1 is 1. If x equals to -1, fx minus 1 is 2 times e to the power -2 minus 1. So this 3 point is this and this, and we can add these two curves, get its basic shape is like this. So this is the image of distribution function fx.